I'm only here for that title. That's the only thing that actually made this happen. There's no revolutionary hard crypto in my talk. It's not quite as exciting as the title makes it sound. Almost everything in there isn't a lie, but it's not as clever as you might think. It's really just some amusing whimsy that I had a little while back. And you're all really tired and you're all thirsty, and I'm the last man keeping you from beer. So I figure if I cut out all my slides and say any questions, I'll get the best talk award. But don't worry, there's absolutely nothing for you to learn, so you can safely go to sleep. So this is a talk about procrastination, and this is the talk about the sorts of bad things that can happen when you decide to procrastinate. Of procrastination. I could check my email. Answering that question is kind of procrastination. So I started at Catalyst about 2 years ago. Oh, by the way, the logo's gone. I work for Catalyst. We're hiring. Come and see me later over beer or at the job track tomorrow from 1 till 3 p.m. or Jen over here, or there's a number of us scattered around, but none of them are here to see me. Oh, Travis is over there. Oh, and Sir Kent. Come and see any of us, and we'll try and hire you. So I was hired about just under 2 years ago to work at Catalyst. And I was actually their first, I was the first person who was hired specifically to be a Python dev. There was a lot of great Python developers at the company, but I was the first one to be hired to do Python. And it was really exciting to get on board. And 2 months after I got there, the project that I was hired for got canceled. So suddenly I was a Python developer with no Python to do. So I got kind of absorbed into another team and ended up doing work in JavaScript and Perl and other languages like that. But I wanted to keep playing around with Python. So I sort of kept my hand in by doing fun things in my own time. At Catalyst, we use a lot of Catalyst is an open source specialist company. We use a lot of open source tools. We use use MediaWiki for our internal wiki. We use a lot of well-known open source software. And we also home grow stuff when we need to. So we have a paste bin. I will demonstrate it just briefly. It literally just is a typical and it pasted it, and the URL's there, and you stick it in the IRC channel, and it's maybe the output of a command or a piece of code or whatever. That was something that was internally grown by a former colleague of mine named Martin Smith. It's simple. It does syntax highlighting. It doesn't need a database backend. It's just kind of a straightforward little thing. One trick that it does is it uses the md5 sum of whatever you pasted to decide on the URL that it's going to go. So it's not just like a database increment counter like a lot of paste bins use. So anyway, I wrote a script to be able to pipe things directly into the paste bin. I needed a utility, which was I was outputting commands, and I was like, oh, you pipe it into the thing. It'll post it to the paste bin and print out the URL. It looked a little something like, where's my controller go? There. Like that. Ignore all that, that's just comment. That's actually just a reference of all the different syntax highlighting that the Perl paste bin script actually will do syntax highlighting for. I don't know what any of those are, but the actual code is just those 2 lines. It was just a clever curl command and a bit of piping. And I documented it, look at that. I've got documentation, I'm so proud. And the documentation sort of refers to this. And I had this idea in my head that I thought it would be really fun if that URL did actually point you to the paste bin, to the paste of this script, right? But you can't do that, because if you change this here and then you paste it in, you end up with a different URL. And then you change it to match that, and you get nowhere. You just chase your own tail. So you know. So that wasn't procrastination. That was actually a handy script for my colleagues. It was a useful thing that people might want to write, might want to use. Because why wouldn't you, right? So if you start with a story, you paste it in, and you can have decision tree in there. You can put links in. you see a grizzly bear, do you want to run left, go to this paste? Do you want to run to the right, go to that paste? I thought it would just be a fun thing to do. Someone at the company, I wonder if Francois knows, someone made an adventure in the wiki at Catalyst a long time ago, and it's a little out of date because everyone's desks move around a lot, and if you're unlikely to be eaten by a grue on level 2, that's where the sysadmin, maybe you are likely to be eaten by a grue on level 2, but no one had done anything like that with the paste bin. I have no idea why that seemed like a good idea, but maybe because I was procrastinating. So how do you create links when you don't know where the pages will end up? Because the MD5 sums are going to be different every time. You can't set, well, they're based on the content. Sorry? Exactly. Check this out. If you post your pages in reverse order, then you can actually, you paste the final page of your story, and you'll know what its URL is, and you can update the links in the other ones. So what's the problem with doing it that way? You can't have any loops in it. You can't, because, the same problem with the self-referential paste before, the self-referential script. It's cheating. So yeah, you've got it dead right. My plan was to write an acyclic directed graph of story pages and post them in reverse order with a script that would update the links as it went through. So that was the plan. And then actually, they do pay me to do real work. So 6 months later, I hadn't actually gone down this road and tried it out yet, but the idea was still ticking around in my head. But I wasn't really happy with it. I really did want loops in my maze. I wanted to know, could you do it? MD5sum is considered to be a broken algorithm, right? It's not considered safe for cryptographic use anymore. There's a lot of reasons for that, mainly because you can generate collisions if you're good at this stuff. I'm not a mathematician. I'm not a cryptographic expert. I know enough about cryptography to know that I must never try to implement it myself, which is actually an important lesson. So I was not going to be able to find a way of algorithmically cracking MD5 sums to choose the hash that I wanted. So I just brute forced them. As Jeremy Clarkson once said, how hard can it be? Okay, so let's talk about Cython for a minute, because I had to make this talk actually technical about something. Who's used Cython? Who has no idea what I'm talking about? A couple people, cool, okay. You could call it a dialect of Python, or you could call it a Python to C compiler. What it kind of is it's a language that looks a lot like Python and can look exactly like Python, but it has a couple syntactical constructs that let you define C types. It lets you define, instead of like, actually I have some example code, I think. Right, actually no, so this is straight Python code, which doesn't have any CPython declarations in it, Cython declarations in it. And Cython will compile this code into a C extension module. It'll convert it into C that can then be imported as a Python module. And doing it that way will give you some speed up. It'll give you like a 30% speed up, I think, in their usual speed tests. But you get a really good speed up. Sorry, these code samples, by the way, are from the Cython documentation. I didn't write these. I cribbed them wholeheartedly. Here's the same code, but it's actually got a couple C declarations in it. It's saying that those are doubles going into the function, and it's declaring those variables as certain C types. So you leave behind all of the Python object mess. And that example there would almost compile into pure C without Python stuff. It still does have Python stuff in it because of the range function. But that would give you a couple orders of magnitude of speed up. This is almost pure C, even though it looks like Python. And that's what I love about this stuff, because who writes in C? Not me, and I'm so happy about it. I used to do C, and I don't anymore, and I don't miss it much, but sometimes you just need the speed, and sometimes you need to be close to the bare metal. So this is a great middle ground. This gives you compiled C as an extension without actually having to deal with pointers. So basically, if you're lazy, you can use Cython to just squeeze the dead weight out of your inner loop. If the inner loop of your code is an algorithm that you can just plow through somehow, if you can squeeze that down to C, then things will get an awful lot faster. So how do you get the md5 sum you want out of the file you've got? Well, start with the file you've got, grab it, it's md5 sum. Now the md5 sum module in Python is like a file reader. You can feed it chunks of data at a time. So feed it your file, then make a copy of it, and then throw a bit of a suffix on, just a random. I just started with integers. I just threw the number 1 on the end of the file and did that, and then ran the md5 over it, and did that match? Nope. Okay, I'll try 2. Okay, I'll try 3. Okay, I'll try 4. So after all, it's going to match eventually, right? You've got a 1 in 2 to the 128 chance of it just matching coincidentally, which is too long. But if you were paying attention earlier, you saw that those URLs were not 64 bytes long. They were only 6 bytes long, which were hexadecimal, which is 24 bits. Why do I look directly to Rob to do the weird math?
6 times 4 isn't that weird.
Yeah, it is. It is at 4:45 p.m. on a Saturday. Anyway, I only had to guess 24 bits, which is 16 million. So every time I incremented the integer, I had a 1 in 16 million chance of it just being the md5 sum that I wanted it to be. And modern computers eat numbers like 1/16 millionth for breakfast. So using this function, I was able to get the md5 sum that I wanted out of any file that I wanted. So I would have a text file, and I would go, I want its last 6 digits of its md5 sum to be A. And then 10 minutes later, it was. Except 10 minutes was actually really annoying. I wanted to make it faster than that, right? I love the fact that modern computers have 8 cores. You know, they start at 8 cores now, I think. Now, I am not an experienced multi-threaded programmer. I've managed to avoid that most of my life, which also kind of like the C thing, thank goodness, because it's messy and terrifying at the best of times. And in Python, it's not the best of times. Multi-threaded programming in Python is a nightmare because of reasons. This is me not understanding the problem. So it's enough to not try and explain to someone why you don't use threads in Python. You just sort of go, yeah, no, try something else. Try multiprocessing. Multiprocessing looks just like threading, but you're actually forking the process. And who went to the talk this morning? I unfortunately missed it, so I probably could have learned. You probably know more about it than I do now. But I wanted a way of farming this work out to 8 CPUs because it's a massively parallelizable task. And so I ended up with something like this. Look, I hardwired the number of CPUs. It's very bad of me. Essentially, you just build a pool of workers. And remember, you're just trying random integers. So you can just have one worker start at 0 and increment each guess by 8. So it's trying 0 and 8 and 16 and 24. And see, I can do math. And then the other one, the next worker will do 1, then 9, then, oh no, I can't, 17 and 25, right? And in that way, you've got 8 workers that aren't going to step on each other's toes, just plowing through trying combinations. And then the only hard part is telling them all when to stop. One of them will find the solution, and somehow it has to signal to the other ones that it's time to stop. So Some of the mess in there is that little finish value is a multiprocessing semaphore that will signal to the other workers when one of the workers has found the right MD5 sum. And that sort of operation is actually pretty expensive and slowed it down by an order of about 15,000 times or something. So what you actually do there is you only have the other workers check if you found the solution after every million or so guesses. So each worker will try like 1,000,000 things and then check and see if one other worker has found it and then try another 1,000,000 and just go on like that. And that way you don't have to worry about that inefficiency. So by this time, I had 8 cores running 8 processes, no global interpreter lock to get in the way, running Cython compiled code. Now, the Cython was not giving me the big speed up that you can sometimes get because I was relying on the Python md5sum library, which I don't think is native C. I think it's actually just a pure Python implementation, but I'm not sure about that. But it didn't matter because by this time, the cracking of a single file could take anywhere between 3 and 30 seconds. So at this point, I was pretty happy. And I didn't actually need to do any more optimization. So I just had one more thing that I really wanted to solve, which was every single one of my silly little files has a honking big integer at the bottom of it. And it's just sitting there looking ugly, and it might make people start to wonder how these got there and how I actually solved this thing. So I wanted to make sure that it wasn't obvious how I had done this. Because, you know, it's not a magic trick if the mirrors are like standing right there, right? And so how do I hide a chunk of random cruft at the bottom of the file? At first, it was just counting integers going up. And I wanted to try some other things. Like, it didn't have to be integers. I could try any random combination. I could try random strings. At first, I was playing around with, you know, a little chunk of text at the bottom. So, you know, just sequentially counting up, but doing something else like that. And then I started to get silly, and I started looking at sort of randomly generating grammatically correct sentences. So there'd be kind of a nonsense sentence down at the bottom. And I actually went down this road for a little while before realizing that there was actually a much, much better solution. So the ASCII character set has 5 white space characters. It's got space, tab, vertical tab, line feed, carriage return, form feed. Was that 5 or 6? Sorry? Backspace. I didn't try backspace. That would have been pretty funny. In any event, just using those 5 white space characters, you end up with, all you have to do is take your integer, because you're still just counting up and counting guesses. Take your integer, convert it to base 5, and replace each of the numerals with a different character from your new alphabet, which was, those 5. So space, tab, /n/r/f, whatever they are. Who knows? They're things. And the beauty of doing that in the paste bin is that the paste bin is black text on white background, and so there's no sign of anything weird there. So I had everything working and ready to go, and then real life got in the way again. Because I do have a day job, and sometimes people want me to write code for them that isn't ridiculous. I know, right? Money, I guess. So, and also because I had to come up with the maze now. All of the text stuff was done. It was working and it was fine, and now I actually had to write content. Who here has written the code for their blog more times than they've written in blog entries? Yeah, come on, admit it. In any event, one day, about 3 months ago, this showed up in the Catalyst paste bin with a random anonymous link in the IRC server putting you up to it. Hang on a sec, let me just make the thing a little bigger. And you would go to the next thing, and it just led you nowhere. And you would go to the next thing, and you'd be like, oh, come on, what the hell is this? This is boring. What's going on? Oh. So the script that actually generated the maze was kind of fun to write, too. I should release the code for that. But I kind of had to come up with a little domain-specific language, which was, the east door leads to the west door of the thing, and the hardest part was honestly just coming up with enough stupid, boring, wacky movie references to fill up all of the pages, until you ended up back at the start, and some people realized, wait a minute, something really weird is going on. I don't even know what some of this stuff is. So I anonymously uploaded it, and I just couldn't wait to see people's reaction, and nothing happened. Nobody even noticed for like 2 days. And then on the third day, one person who'd seen, I set the subject, and we have a hash catalyst chat channel on our internal IRC server, and someone noticed the URL sitting in the topic there and looked at it and went, and of course, Catalyst being a company full of techies, he gets about 2 links through. This is a colleague of mine named Chris Forbes. He goes through 2 or 3 pages and he goes, I'll write a script. So he wrote a script, which scraped the entire maze and drew a GraphViz visualization of it, posted that in the channel, went about his day, decided that it was a done deal. Spoiled my fun a little bit. Tell me about it. But actually, what I was pretty pleased about was that the end of the maze is not in there, because it's not linked to by anything else. It's, you have to actually go through the maze and find the clues to uncover what the URL was for the last page. So, because I knew someone would do this. I knew someone would scrape it. And so the actual final page was not there. But I had to, a week later, point out to people, also anonymously via the IRC mechanism, that actually this wasn't a solution. And also point out that I did have a bottle of something for whoever found the prize, whoever found their way to the end. And that actually motivated people. So a few days after that, another colleague named Aaron Wells did find his way through the maze and found the Twitter address that I used, because anonymous email is hard to come by these days. It doesn't work very well. So signing up anonymous Twitter accounts does work. So that's how I sort of had them contact me, because I was trying to keep it reasonably anonymous, which failed later for other reasons. But in the meantime, it was a lot of fun. And like I said, you've learned nothing useful today whatsoever, other than don't trust me with anything, I guess. But if I had to bring this back to something useful, it would be use procrastination to learn something new. The thing that I had the most fun with this little side project was, first, discovering that something could be done that I didn't think would be easy to do. Secondly, discovering that multiprocessing was actually pretty easy to use, and that Cython was pretty easy to use. So it was an excuse to learn a bunch of technologies that I wasn't using in my day-to-day. Plus, for a big chunk of that time, I wasn't working on Python anyway, so it was good to keep my hands on. And finally, use your constraints to learn something new. If I had write access to the server, if I was able to edit these files directly, what would be the point? There'd be no fun, right? So the fact that I couldn't do it any other way was the whole part of what made this interesting. And that's it. Thank you very much for your time.